Just look at about the ones complement first. In ones complement, if you add two numbers or subtract two numbers from a minus b, let's take a minus b. In this, step 1 is do the ones complement for b, and let's take it as b1. Step 2, add b1 means this to a. Step 3, if carry is generated, means carry equals to 1, then add carry to the result. క్యారీని యాడ్ చేసినప్పుడు ఏమవుతుంది, రిజల్ట్ అనేది పాజిటివ్ అవుతుంది. రిజల్ట్ ఈస్ పాజిటివ్ నెంబర్. ఎల్స్ క్యారీ జనరేట్ అవ్వలేదు, రిజల్ట్ అనేది నెగిటివ్. రిజల్ట్ ఈస్ నెగిటివ్ నెంబర్. నేను ఎస్టర్డేస్ క్లాస్లో ఆల్రెడీ డిస్కస్ చేసాం. ఇఫ్ ద రిజల్టెంట్ ఈస్ నెగిటివ్ నెంబర్, దెన్ అగైన్ యూ నీడ్ టు డూ ద వన్స్ కాంప్లిమెంట్ ఫర్ ద obtained result. Okay, is it clear? Guys, please respond. Hello. Hello. Anyone from the class, please respond. Hello. Hello. Guys, am I audible? Am I visible?
Yes, ma'am.
Yes. Please cooperate with me, okay? Just try to respond for the is it clear or not? Something like this. Any doubts regarding the ones complement?
No, ma'am.
Okay. Shall I move to the next one? Two's complement. Same as like as ones complement. In two's complement, just you need to add one for the ones complement form. Let's take a minus b. In step 1, you need to do two's complement for the b, and obtained one is b1. Step 2, add b1 to a. All the complement forms is same. Okay. All R's complement and all R minus 1's complement are having same method. If carry is generated in two's complement method, you just ignore the carry. Then it result is positive number. Else result is negative. Two's complement. Then the number is in the form of two's complement. Okay. Is it clear? Hello. Guys, is it clear? Hello. Shall I move to the next part? Any idea about the overflow, guys? What is overflow? What does overflow means? Any idea? Overflow is nothing but when two signed two same signed numbers are added together, then the result is overflow condition. Okay? When same signed numbers are added together. Then the next topic is classification of codes. In number systems, you are having so many types of codes, right? 8421 code, weighted code, non-weighted code, sequential codes, and all those things. Now we'll see what are all those codes. In this classification of codes, mainly the codes are classified into two types. First one is numeric codes, and the other is alphanumeric codes. In this numeric codes, we are having weighted, non-weighted, self-complemented, sequential codes, error detection, error correction codes. In this alphanumeric one, we are having ASCII numbers and all those things, right? ASCII, Unicode means each one is having same single code for single representation. And the next one is Hollerith code. Are you guys clear about these codes? Mainly, numeric codes means it represents the sequence of binary digits. Hello. 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 Alphanumeric codes means okay guys, is it clear? And the next one is weighted codes. Weighted codes means which obeys the positional weight of a number. Given code is having the specific position codes means specific weight for each position. Example 8421, 421, BCD. All these are the examples for weighted codes. And next, non-weighted. It doesn't have any fixed position for each numbers. Like examples, gray code, XS3 code. All these are the examples of non-weighted codes. And the next one is self-complemented code. In self-complemented code, whatever the code you have, right, it is the self-complement after certain digits. Like it acts as a reflective code. It is also known as a reflective code. For example, 2421, 5211, XS3. All these are the examples of the self-complemented code. Means, let's see, self-complement means if we are the result of the ones, let's take one's complement number. One's complement of a given number is results in nine's complement. Let's take an example. 000100 means it's 4, right? One's complement of this number is 1011. Means it is positive with 5, one's complement method. Let's take the nine's complement for this. Nine's complement is nothing but 4 is 5. Nine's complement of a 4 is 5. Okay. In 2421 code, okay guys, then sequential one. In sequential one, each next bit is one bit differ from the preceding one. Each from 1 bit, like 8421. In 8421, 0 is represented as all zeros, 1 is represented as triple zero. Only one single bit is differ from the preceding bit. Sorry guys, sorry for the disturbance. I'm having improper network here. Okay, shall I continue? Okay, let's see. The the number is valid BCD, means there is no corrections. The number is in between 0 to 9. In this valid case also there is, we are having another type, valid BCD with carry. If carry is generated, then correction is there. Means you need to add 6 to result. Okay. Are you guys clear about the BCD addition? Can I move to the next code, that is gray code? Next one is gray code. Gray code is also nothing but a cyclic code and self-reflecting code. Okay. This gray code is only used in analog to digital conversions, mainly to reduce errors in the correction. Binary to gray and gray to binary conversions, all these conversions are very easy and simple in nature. And this is also used to measure angle of rotation of a wheel. Let's take a wheel is rotated with some angle. There, how much angle is rotation? To measure the angle of rotation, we use gray code. And gray code is a non-weighted code. Okay. And in this main operation is XOR operation. What is XOR first? Let's take two inputs and the output is y 00011019. If the inputs, both the inputs are same, then the output is 0. If the inputs are different, then the output is 1. It is the XOR operation. Okay, based on this XOR operation, all the gray code conversions are depends. Conversions. Let's see first. Binary to gray code conversion. In binary to gray code conversion, let's take B0, B1, B2, B3. All these are the binary inputs. And you need to convert these binary inputs into the gray code output. Means Z naught is A as same as the B naught. And then XOR operation of B naught and B1 is Z1. XOR operation of both B1 and B2 is Z2. Z3. Okay. Let's take a simple example. 0110 is your binary input. Then you need to convert this as gray code. First, you need to write 0 directly and then 0 XOR with 1, you are getting 1. 1 with 1, you are having 0. 1 with 0, we are getting 1. 0, 1, 0, 0, 1, 0, 1 is your gray code output. And then getting into the gray to binary conversions. Here the inputs is gray code bits, means Z0 to Z3 is your gray code input bits. First, same as Z0, we are getting B0. Same as G0, we are getting B0. And then this is XOR with Z1. B0 XOR with Z1 results in B1. And then B1 XOR with Z2 results in B2. B3. Let's take a simple example. 0110. Same. 0. 0 XOR with 1. 1. 1 with 1, we are having 0. 0 with 0, again 0. Okay. And the next one is XS3 code. Sorry. This is the representation of XS31. Whatever the value you have taken from the BCD value, you need to add 3 to the result. Okay. Then XS3 addition. Let's take A plus B. If carry is generated, add 3 to result. Else subtract 3 from result. Okay. This is the simple XS3 addition one. Shall I move to the next part? That is error correction and detection. In this error correction, we are having you need to add extra bits for the checking of whether the transmitted bit is correct or not. To detect, you need to add extra bits. Means these extra bits is nothing but code words. C0, C1, C2, and so on. You need to add these bits. If it is a valid code word, no error is detected. If it is invalid, error is detected. Okay. For detecting the error, single bit error, the distance between the code words is at least 2. Distance is at least 2 per single bit. Okay, guys. For detecting the single bit error, the code word distance is at least 2. For correcting the single bit error, the code word distance is at least 3. Shall I move to the parity code? Parity code. This is used for detection. For detecting the error, you are using parity codes. In this, firstly, we are going to check whether the binary code word is odd or even. Checking whether binary word is odd or even number of ones. Okay. In this, we are having data bits, parity bits. Data bits is nothing but the message bits. We are adding parity bits to the message bits for getting the even number of ones. First step is you need to check whether the binary word is having even number or odd number of ones. If the binary word is having odd number of ones, then you need to add the parity bit to get even number of ones. By adding parity bits, any odd number errors are detected. Okay.